Morning, everyone. Kind of getting set up right here. Hey, we're tackling 11-1 part 2 today. So actually this is 11-1 part 2. All right. So as you guys watch these, I know some of you are probably not taking notes. Probably want to take notes because you'll be able to use notes on tests and different things that we do. And if you don't have your notes available, you're out of luck. So make sure that you're using your uh, note taking abilities because we need to make sure that you guys have this stuff at your disposal at all times. All right. So today we're talking about missing sides of trigonomic functions. So you're going to need three things. So in the problem, you're going to need one. You're going to need three of these things. You're going to need one side, an angle, and a right triangle. And so that'll give us the information that we need. You need at least one of those things to make it work for the three things that you need. Steps to apply. So if I'm looking at a triangle, I need this angle and let's say this side. I need a hypotenuse. If I've got those two things and I know that this is a right triangle, I'm good. Okay. There are problems. This is you need at least these three things, but you can also get away with two sides only. You can also have two sides only. You have two sides only, and then you don't need an angle. So if you get two sides, they give you opposite and hypotenuse, you don't need the angle. But everything has to be a right triangle. This has to happen. That always is a have to. All right. So when we look at this, when you have the pieces that you need, you can apply these steps in order. So one of the things that you guys will know as you move on in math is not every problem is the same. So we're going to teach you concepts that you apply directly to every problem. So if you have trouble, I'm going to ask you questions like, did you draw and label the triangle? Choose your trig function. So that means you got to understand and you got to write down and have at your disposal the trigonomic functions, the 6 different ones. Did you set up your ratio? Remember, ratio is just a fraction. So don't forget your ratio is the same as a fraction. All right. So a ratio is basically fractions set equal to each other. So we're going to deal with fractions, and I'll get into that a little bit. All right. If you have a fear of fractions, it's what we're going to work with a lot. And then after that, your algebra techniques, the ones we talked about in solving equations, you're going to work backwards. You're going to do add, subtract first, multiply, and divide. And then we're going to finish with a calculator. And you can have your own calculator that works. Every calculator is different. So what I explained to you today might not work on your calculator. You'll have to look it up to see. I will use Desmos because Desmos everybody can get onto using their Chromebook. All right, so let's move down to the next piece here. It's got some writing in the book. You can look at the writing on the side. I'm just going to worry about this. The copy machine didn't have a lot of ink today, so it didn't come up very well. So if we look at this, they took this triangle. Here's my triangle. Oops. They gave me one side, which is the hypotenuse. That's equal to 8. And they gave me one angle, and then therefore I'm looking for this side. So to find a side, you have to remember you have to have at least one side and one angle. So from there, we know that this is the reference angle. So if I label my triangle, because remember we want to draw and label, so they drew it out for you. Here's my side. So now I've got my opposite side across from the reference angle. I got my adjacent side, and I've got my hypotenuse. So they give us that ratio. That's my fraction they give us. This is my ratio they give us. Adjacent over hypotenuse. So adjacent over hypotenuse is cosine. Cosine of what? The cosine of the angle. So if we do that, this says 8 over, this says x over 8. Again, this is in your book, so you can follow along in your book. Okay, so x over 8. This here is a fraction that they got from the previous page. You don't have to worry about that. It's also, and I'll show you how to type it in. So they took the cosine of 30, and the cosine of 30 is equal to the square root of 3 over 2. So I'm going to show you a little differently how you do that with your calculator instead. Okay. So on this next problem, I'll show you how they do it differently. Just remember, we're following steps and we're doing different techniques. So it's all about applying the correct steps to the problem. Not every problem doesn't look the same. So once they get their ratio, they multiply both sides by 8 here and by 8 here. So once they multiply by 8, they end up with 8 times the square root of 3 over 2, which is this answer. And that equals x. And then they do this in their calculator, and I'll show you. So you go to Desmos down here, and then, of course, my toolbar is literally in the way. I can't get to it. That's not cool. Let me try this here. All right. Nope. It's not going to let me. That is not cool. I'm going to have to figure out another way to show you. All right, guys. That is not a cool thing to do. So we'll deal with that in a little bit here. I'm going to have to pause it and figure out how I'm going to tackle that. I'll be right back. All right, here we go again, guys. I figured out how to do it, so lucky me. And so we're going to, when you go to this one, so we'll go back to the fact that we're dealing with square root of 8 over 3 divided by 2. So all you do is plug that into the calculator. So you go 8 times the square root of 3, like that. And then you can close this parenthesis out, and then you're going to go divided by 2. And that gives you approximately 6.9. Right here's your answer. So at that point, they plug in their answer of 6.9. So let's tackle this one here. It's blank in your on your notes. So again, you got your 5 steps. I figured out the way to do this. All right. So you've got your 5 steps. In our 5 steps, we draw the triangle. I rearranged it. The triangle that they've given us has a side x for adjacent, and they give us a hypotenuse. So we are looking at the ratio. Step 2, we're looking at the ratio adjacent over hypotenuse. What is adjacent over hypotenuse? It is cosine. That's what we talked about yesterday. Since it's adjacent over hypotenuse, my adjacent side is x, and I put it right there. My hypotenuse is 14, put it right here. And then what is theta? Theta is 60 degrees, so the cosine is 60 degrees. So now we multiply, we're solving for x, so we're doing our inverse operations. So since this is x divided by 14, how do I undo that? I multiply by 14 here, and I multiply by 14 here. Remember, these become 1. 14 over 14 is 1. So my answer is 14 times the cosine of 60. Now, so what I do, rather than worry about the fractions like they did in the previous problem, is I just go straight to my Desmos calculator. I can clear this one out of the way. So let me get rid of the toolbar here. And let's click on that. And I am going, let me bring the toolbar back. And let me put on my pointer there. Okay. And then let's get rid of the toolbar again. There we go. Let's try this one more time. And so we click on here, And I'm just going to go ahead and backspace this. And it was 14 times. And notice how there's no cosine here anymore. Well, if you click the word functions right here, cosine pops up right there. It's under the trig functions. One of the things you need to do is make sure in your settings that you are on degrees. See how this radians is highlighted? You got to click on degrees underneath. So you want to make sure you click on the degrees right here. Let's see if I can show you. Yeah, there it is. You got to click on degrees. And so I made sure it's degrees, and it was cosine of 60 degrees, and my answer is 7. So that's where I end up with this answer here. So the cosine of 60, let's go back one. If I just do the cosine of 60, I get 0.5 right here. If I get 0.5, now when we go back to this one, there's my 0.5. 14 times 0.5 is 7. So as we work with this stuff, you're going to have to be able to use your Desmos calculator. So they give you all sorts of different ways to do it. They give you word problems like this. They're going to ask you to find that is eye level is at 6 feet. So don't forget that the triangle really starts at his eye level right here. So when we draw the triangle, I'm going to move you down here a little bit. The triangle has 6 feet to go with it already. So make sure that you, when you look at examples like this, that you understand that he is already 6 feet tall. It tells you right here, his eye level is 6 feet tall. So calculate the height of the building. And Joel, he's 200 feet away, and his eye level. So then when we look at this here, and again, it's not very clear on this one, but you can, this is an example out of your book. It didn't copy very well. If we take this and we look at this, this is theta. So across from theta is always my opposite. And it's always my adjacent here next to it. Because this is my right angle because it's a building, so this is my hypotenuse. So what do they give us? They give us opposite and adjacent. Well, opposite over adjacent is tangent. So then they just set the ratio up, work through the math, and they get approximately 802 feet for the distance. So if we're looking at this answer here, this answer is 802. And if this answer is 802, then it's 6 feet higher because of his eye level. So the answer is approximately 808 feet. So just make sure you watch out for little tricks like that. So let's go ahead and move on to the next one here. This again is out of your book, but I'll show you the triangle right now. The triangle is this one here. So it looks like that. This one's labeled X, and this one's 11, and that one's 24. So when we look at this, I redrew it so I can see it a little better. I like to do that. So step one, I drew the graph. So don't forget, this is step one. Step one is draw and label. So step one is draw and label. I know that this is my angle I need, so that's my theta. My theta is always across from the opposite. And then my long side across from the 90 is always the hypotenuse. So when I look at this, piece here, I'm given the opposite, I'm given the hypotenuse, and I'm given theta. Well, if I'm given opposite over hypotenuse, that is the ratio for sine. So there's step two. Find your ratio. So my ratio is step two. This is step I'm coming up with a different way to write, guys. It's going to be a while. This is step 2. So then if this is step 2, my next one is to set up the ratios and to do our algebra. So if we look at this next piece right here, I have my ratios set up. Here's my opposite from our given. There's our given right there. Here's my hypotenuse, which is right here. And then sine of theta, theta is 24, so that one's here. So then we got to just do a little bit of algebra work. Remember, since we're dividing, we work inverses. So my inverse is multiplying by x since I'm dividing by x. So I'm going to divide first because remember, it's add or subtract. Then it's multiply or divide. Then it is exponents and parentheses. So we're doing PEMDAS backwards. PEMDAS this way, equations we work this way. So we're right here because we're multiplying and dividing. So since I'm dividing, I multiply both sides by x because what I do to one side, I must do to the other because that equals 1. So these will simplify out to 1, and I'm left with this piece here. Still don't have x by itself. So I go back through, there's no add or subtract, so I try this one more time. But since I'm multiplying, I need to divide. So I need to divide by the sine of 24. So in the next step, I divide by the sine of 24 degrees, divided by the sine of 24 degrees. So that simplifies out to 1. And then I get on the other side, what I do to this side, I have to do to the other side. So therefore, I get 11 divided by sine of 24 degrees. So I take this piece right here and I just go back to Desmos. So let me click on the pointer here and I'm going to go back to Desmos and I'm going to turn, I've got that on. So I'm going to backpedal and I can't remember what it was. So sine of 24 times divided by 11 divided by the sine of 24. So I go 11 divided by function sine of 24. And that gives me approximately 27.04 right here. So if I'm looking at this, 27.04. So my answer is approximately 27.04. So that's the idea behind it. Again, not using anything new except for our trig ratios. So let's move on to the next piece here. And we shall, I got to change that to, all right. So let's talk about inverse operations first. So when we're dealing with inverse operations, we end up saying, oh, look at there, it's multiplying. So what do? We multiply, we divide both sides, and that gives me x equals 5 because we're always looking to undo something. So dividing undoes it invert. That's why it's an inverse operation. It takes apart multiplication. And something like the square, we know that how do I get rid of the square? Well, I take a square root. Whatever I take, the square root of one side, I have to take the square root of the other side. So we're always dealing with inverse operations. So this is where it looks weird, but it's still the same idea. So if I look at inverse operations of trig functions, what I'm looking at is I'm looking at the idea of cosine's inverse operation is cosine of -1. Sine is the sine, the inverse sine. These are actually called arc sine, cosine. But if I'm going to say to the -1 here, because what we're looking for on our calculator is written just like this. They're buttons that look just like that, and they're actually usually above this one. So you're going to use your inverse function on a calculator. So if you look at cosine on your calculator, above it will be cosine of -1. It'll be something like this. It'll have cosine on your calculator. Desmos is different. And then above it, it'll be cosine of -1. And then just look up a little how-to video with your calculator if you're using one and you can't figure it out, because every calculator is different. So that's the idea. So we need to learn to use that in mathematics. So if we're given this triangle here, and I can't see it very well, so let me look at my paper, because it didn't. All right, so we are right here. This triangle is drawn this way, and this side is 10, this side is 10, this side is 6, and they're going from angle N. So angle N is theta, so theta is right here. That means this is opposite because it's opposite of theta, and this is my adjacent. Well, they follow the same exact rule. They draw their triangle, they set up their ratio because we're to look, no, that's not adjacent. What am I talking about? That is my hypotenuse. Glad I caught myself. This is my hypotenuse because it's across from the 90. They set up the ratio opposite over hypotenuse. So they'd say, okay, the sine of n, which we don't know, is opposite over hypotenuse. So now we're solving for the missing angle. And if you remember at the beginning, I said if you're given two sides, you can still do it. They didn't give us an angle, they gave us two sides. So we're working with two sides now. And since we have two sides, we can find an angle. Well, the whole idea is this. How do I get rid of sine? Well, I take sine of -1 of both sides. They skip that step in here. So what happens is I'm going to do the sine, the inverse sine of the sine of n. Well, as we work with inverses, like we know that these two cancel out and I'm left with n. But what I do to one side, I have to do to the other. So here's my n, and they take inverse sine of 6 over 10. And I'll show you in the calculator real quick how to do that. So we're going to go ahead and back this one out. So to find inverse, go to functions. Oops, come back up here. Alt-T. So if we go to functions, notice how right next to sine is inverse sine. So we just go inverse sine, and it's 6 divided by 10. And that, remember, make sure you're in degrees. So always make sure you're in degrees. Once you change it, you usually stay there. So our angle is approximately 36.86 or 87 degrees. And if you go back here, they have 36.9. So they round it a little bit. So that's the idea. Same idea with this one here. It's just with cosine. So let's go to the last example, and it'll explain a little bit better than the book does here. So if we go, we're finding the missing angle. What do we need to find the missing angle? We need two sides. So if we are back, let me bring my menu bar back up. If we are back here, we have our triangle here, and then this side's 15 and this side's 17. So I drew it right here, okay? I drew it right here, and I labeled it, because here's my theta. Don't forget, this is my theta right here, because it's the side I'm looking for, or the side I'm using. So then, therefore, that side's the opposite. Next to it will be the adjacent, and across from the 90 will be the hypotenuse. So now, since this has a ratio, let's go down to the given piece. Let's go to given. I've done step one. I drew and labeled it. And now we're down here. I'm given theta. Theta is the one we're looking for, which is the x in degrees. I've been given my adjacent. I've been given the hypotenuse, so my ratio is adjacent over hypotenuse. Well, what's the ratio associated with that? Cosine of theta. cosine of theta is adjacent over hypotenuse. So I set my equation up. I need to get rid of cosine of theta. How do I do that? I use its inverse operation. Its inverse operation is inverse cosine. Those are going to simplify themselves out. And then what I do to one side, I have to do to the other. So I have to take the inverse cosine of the fraction. We use our calculator for that. So again, we go back to Desmos. Let me go to the right pointer here. And then we'll go to Desmos. And I will get rid of my Desmos. We'll clear this one out again. I'm going to go to functions. We are dealing with cosine, I believe. I can't remember now. Cosine, yep. Cosine, dealing with cosine, and the fraction is 15 over 7. So the cosine of 15 divided by 7, here's my answer right here, 28.07 degrees. So I end up with a theta of approximately 28.07 degrees. All right, guys, that's it for today. We'll talk to you later.